Hi you guys, I'm going to try to explain this fairly quickly so you are entertained for this whole video. Okay, I am trying to simplify radicals, and basically step number one that I like to do, and so I'm going to keep referencing this paper, I'm going to try to make sure it stays in the screen, is to write my list of perfect squares. Okay, so let's start off. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, 11 times 11 is 121, 12 times 12 is 144. And I just usually go up to 12, and if I have to for other problems, I can go further, but usually that does the trick. Okay, so let me explain how to do this. So we start with the square root of 800, right? And we're trying to say how to simplify it. Which of these perfect squares goes into 800? And the larger the number is, the quicker we can simplify it. Okay, so we notice, 100, that's usually a pretty easy one to use. So you can see that? Okay, 100. So I'm going to just write underneath it, and I'm going to say that's the same thing as 100 times 8. All right, now I put my perfect square first. The square root of 100 is 10. So when I square root this, it pops out. So 10 radical 8. Now, a lot of times we think we're done, but this number under the radical, we need now to check again. Is there a perfect square that goes into 8? Well, 4 does. Okay, so I'm just going to bring this down and do the same thing I did before. 4 times 2 is 8. The square root of 4 is 2. Boom, that pops out, but I already have a 10 there, so I have to multiply those numbers. So now I have 20 radical 2. Okay? All right, I'm going to try to do this fairly quickly here. I need for you to see these perfect squares. I'm going to keep referencing this list. Okay. And what you can do is, if you're not great at division, you can just, type in these different numbers in here, but we want to always use one of these. Okay, so I have the square root of 108. Well, usually I try 16. I know 9 goes into 108. Let's try 16. 108 divided by 16. Oh, see, that got me a decimal answer, so that's not going to work. 108 divided by 9 is 12. Okay, so I'm not going to put 12 first, I'm going to put 9. 9 times 12. Okay, the square root of 9 is 3, so that pops out. Now I have to double check. Is there a perfect square that goes into 9? 4 does. So I have 4 times 3. The square root of 4 is 2, but there's already a 3 there, so that 2 times 3 is 6, radical 3. All right? Okay, so let's move on to our number 2 here. I'm going to kind of use this paper so I can keep referencing this. Okay. So now this is like a division problem almost, but I can break this apart. Sometimes it's helpful to keep them under the radical, and sometimes it's helpful to view them almost like this, like that it's like radical 15 over radical 64. And one of the things I look for is one of these already on my list? So see how the denominator 64 is a perfect square? So that makes it really easy. If I separate it like this, well, this is a perfect square. So the square root of 64 is 8. I don't even have a radical anymore. And then this gets simplified. Now I need to double check. Is there a perfect square that goes into 15? Nope, I'm done. Okay. All right, so let's look at this one over here. I'm looking at 198. 198 divided by 2. Okay, so here, do you see how neither of these are perfect squares? Neither are on my list. So it's not super helpful for me to, separate it, but I know that 198, 2 goes into 198. So I'm going to get 198, I'm going to divide it by 2, and I get 99. Okay, so this number here is the same as the square root of 99. Now, is there a perfect square, bingo, that goes into 99? 9 does. Okay, and that is 9 times 11. So I have 3 radical 11. Okay, so this is the simplified version of that. All right, we're going to keep moving down here. 147. Keep my list handy. Handy dandy. Look over there. Okay, so 147. I'm trying to see what perfect square goes into 147. Now, at first I thought it was nothing, and then if nothing goes into that, we would just be simplified. We couldn't simplify it anymore. But 147, I'm gonna say, you know, maybe I start off with 81, divide by 81. Nope. 147 divided by 49. Yeah, that worked. Okay, so when I break that apart, I have 49 times 3. The square root of 49 is 7, so 7 radical 3. All right, if we look at number 5, right away, you should be starting to memorize these perfect squares just because you're going to use them a lot. I mean, you can write them down, right, which is totally fine if you're not comfortable, and on a test you can write them down. But if you notice, like this jumps out to me that the square root of 36 I know is a perfect square. So in my mind, this is what my mind is doing. My mind is breaking that apart and going, bingo, that's a perfect square. So I automatically know I have a 6 there because the square root of 36 is 6. I have this radical 11, and I can't simplify that because no perfect square goes into 11, so I'm done. All right, let's look at number 6. On the side there, I have 624. I noticed that 3 is not a perfect square, so I'm going to start moving and grooving here. Make sure you guys can see that. So I'm going to divide 624, hope for the best, see if it's divisible. It is, and I get the square root of 208. I now have to think, what perfect square goes into 208? Well, it's funny, a lot of times I try, you know, 36 or 16. Let's just see. 36, nope. 208 divided by 16, 13. So now I have 16 times 13. The square root of 16 is 4, radical 13. All right. Now, if you look down here, this is the same idea, except for this is with cube roots. Okay, now in square roots I can't have negatives under these radicals, but in cube roots I can. So we're just going to keep moving here, except for instead of writing my perfect squares like I did before, now I need my perfect cubes. So to do that list, I just go up to 5, my perfect cubes. 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, 4 times 4 times 4 is 64, 5 times 5 is 125. Now I've kind of memorized this list because I've gone on and on for so many times. But that's really usually all I have to do for right now. If I have to go a little further, I can, but we'll see as we get there. All right, so let's look here at this problem. We're going to say same idea, right? What number, but this time it has to be from my perfect cube list because of the index numbers of 3. So what perfect cube goes into 128? Well, I don't know. 128, maybe 8? Yes, 8. Okay, so I have 8 times 16. All right, so this is cube rooted. All right, so the cube root of 8, and I can make that a negative. So the cube root, because in here I had a negative, so the cube root of 8 is 2, so I'm going to go ahead and pull out negative 2, keep my 16 under the radical sign, and then is there a perfect cube that goes into 16? Oh yeah, there is, 8. 8 goes back into that. So same idea as before. I now have 8 times 2. The cube root of 8, sorry, keep forgetting, you guys can't see everything. Okay, so let me back up here. I did negative 8 times 16, then I cube rooted the negative 8 and I got negative 2. That 16 got brought down. I noticed that 8 goes into 16, 8 times 2. Now I'm where I am. I'm going to find the cube root of 8 is 2. There's already a negative 2 out there, so that's now negative 4 cube root of 2. All right, let's look at this one here. I noticed none of these numbers are on my perfect cube list, but I'm going to have to look at the denominator and see if I can somehow simplify that. So let's go to town. All right. Sorry, I have all these papers because I keep having to redo these videos when I make mistakes. Okay, so I'm going to break this apart just because I'm thinking, what else can I do here? Break it apart and see if that helps. You know, sometimes you got to try it out. All right, so now 216. Now, I'm just curious what the next number would be. So I have, this is, you know, this is a perfect cube of 5. So if I try 6 cubed, oh, I get 216. So this is a perfect cube. All right, so now I'm gonna have my cube root of 9, and on the bottom, just a 6. Because if I had to extend this list here, the cube root of 116 is 6. All right, so that is my answer, and I cannot go any further. I can't simplify the 9 and the 6 because that's under the radical, and that is not. Okay, almost done. Let's look here at the cube root of 135. I have my little list of cubes, of perfect cubes, which I'm going to keep going back to. And what perfect cube goes into 135? I don't know. Let's try 8. No. 135. Let's try 27. 27 worked. Okay, so that breaks down to 27 times 5. The cube root of 27 is 3. And at this point, we should be, you know, kind of easy to do. All right, I wanted to show you this one really cool thing about if you have letters involved. It doesn't happen that often, but every once in a while, it's just not very hard, so I wanted to show it to you. And I'm gonna kind of make you draw a picture. I don't expect you to do that picture every time, more like that's what you're picturing in your head if you need to. Okay, so it's asking for the square root of x to the 4th, b to the 5th. So that means I would have 4 x's here, right? And I would have 5 b's, 1, 2, 3, 4, 5. Okay, so if I'm finding the square root of this, I'm basically putting this in groups of 2 because this would be a 2 if it's square root. Okay, so I have a group of 2 here, a group of 2 here, a group of 2. They have to be the same letter. Okay, so my final answer, I'm gonna put x, this is gonna come to the outside. And I have 1 group on the outside, and I have 2 groups on the outside. Same for b's, I have 2 groups. But then this little lonely guy did not get grouped, so he has to stay there by himself. All right, now some of you will say, well, wait, Miss Knight, can I just divide that by 2? Yeah, you can. You can say, okay, 4 divided by 2 is 2, so my x's have 2's. I really need for this to be an even number, so you could say, well, that's the same thing as like b to the 4th and b, divide that by 2, and it comes out. That will totally work as well. Okay, here, last example, the square root of 25. That's just a normal number, so I can say the square root of 25 is 5. Now inside, I have 1x. I have 6 y's. 1, 2, 3, 4, 5, 6, and 3 z's. And then you're going to say, well, because this is square root, I'm putting them in groups of 2. I have a group of 2 here, a group of 2 here, a group of 2 here, a group of 2 here. Okay, so let's start off. Leave a little space. You see how I can't pull any of the x's out because they're not paired up, so I have to leave one there. I have 3 groups of y's, 1 group of z's. I don't really need a 1 because it's a 1, and I have 1 z left over. Okay, now just if you did it the other way, what you're doing is you're saying to your, whoops, that's a 3. You're saying to yourself, okay, I really want these exponents to be even so I can cut them in half because this is a 2. So you deal with the 5 here, but then on the inside, you're kind of thinking about it like that. You can't make that even, right? This is already even, but you can say, okay, that's just like z squared and a z. And then here, you can't pull that out at all, so that has to stay in. Half of 6 is 3. Half of 2 is 1, and that can't be pulled out. Okay, you get the same answer either way. All right, have a good day.